During the summer of 1963, President John F. Kennedy unveiled a significant new aviation initiative.
Strong faith in the future.
He challenged America to develop and operate a supersonic jet capable of cruising beyond 3,000 kilometers per hour.
Program in civilian aviation. Supersonic flight.
This narrates the tale of Kennedy's vision, a machine at the absolute frontier of engineering. A craft intended to soar quicker and loftier than all competitors, the Boeing 2707. Among John Kennedy's inspirations was John Glenn, the initial American to orbit Earth. Yet Glenn was also the pioneer who crossed the American continent at supersonic velocity back in 1957. From that moment on, Kennedy had envisioned creating an American supersonic passenger transport. Different nations shared that ambition.
The British began their supersonic aircraft program in 1943, midway through the war. It was a design, obviously, at that stage, which called for an aircraft to be capable of Mach 1.5. That's 1.5 times the speed of sound, or about 1,000 miles an hour, which is really quite adventurous when you think about the speeds they were achieving in those days.
The British pursued various concepts. Notable examples included the Miles M52 and the de Havilland DH-108 Swallow. However, Britain lost the ultimate race to Chuck Yeager, piloting the American Bell X-1.
To tell you the truth, I was hopping mad, because I realized we could have done it and we'd missed the boat by a cancellation. Not with the DH-108, but with the Miles M52. I was to be the pilot of the Miles M52, so I'd followed this carefully, and we were 80% ready for the first flight, when, without any warning, without any consultation, the aircraft was cancelled.
On October 14, 1947, the rocket-driven Bell X-1 stood as the first plane to exceed the speed of sound.
The British were really upset that the Americans had been first through the sound barrier, because British technology was ahead of the Americans. The British just fluffed it, lacked the guts to do it.
The explanation the British offered for halting the Miles 52 was insufficient data regarding the physics and airframe encounters near the sonic wall.
When an aircraft approaches the speed of sound, several things happen. The most disturbing of which for the occupants of the aircraft is the aircraft begins to shake and rumble, depending on how rapidly or how slowly you approach the speed of sound. But in aerodynamic terms, a wave builds up, an area of compressibility builds up, a shock wave. And what that does is that causes increased drag and increased heating on the aircraft, such that as you approach the speed of sound, as the shock wave passes over the flying surfaces, what that does, it causes the wings to lose lift both above and below the wing. And that has a downward effect on the aircraft. So the aircraft will start to dive if you don't do anything else about it.
A technique for managing this involved utilizing hydraulic control surfaces, specifically the tail's elevators. During subsonic travel, air passes over the airfoil smoothly to generate lift. But in the transonic phase, a shock wave develops which produces significant drag. At sonic speeds, this wave rests on the wing, exerting a strong downward force. Hydraulic flight controls remedy this by pushing the aircraft's nose upward.
You'll first start to notice the problem of approaching the transonic area, approaching the speed of sound from about 0.9, so 9/10 of the speed of sound at sea level. And there you'll begin to experience a buffet as the shock wave begins to build up. And as you approach the speed of sound, the closer you get to the speed of sound, the greater that buffet will be, until that moment when you pop through the other side and that shock wave is then traveling behind the aircraft. You then punch through into an area of far more stable air, an area of almost quietness, if you like.
By the mid-1950s, combat jets were frequently breaking the sound barrier, though only for brief intervals. Maintaining supersonic cruise proved a far greater hurdle than simply piercing through the sound barrier once.
Supersonic flight for passengers is actually very different from supersonic flight in the military context. If you're going to fly passengers at supersonic speed, you have to fly them for a long, long time at high speed, whereas military operations tend to be a quick dash.
Just one nation chose to confront this difficulty. Having lost the initial sonic race, the British then began the creation and refinement of a supersonic passenger liner. This marked the beginning of a competition that would fundamentally reshape the landscape of global flight. On March 10, 1956, Britain reasserted its dominance in the high-speed arena when the experimental Fairey Delta II shattered the world absolute speed record, reaching 1,820 kilometers per hour. The Fairey Delta II debuted several groundbreaking innovations. It featured a slender delta wing, ideal for sustained supersonic cruising, and a tilting droop nose to provide pilots with necessary visibility during takeoff and touchdown. Encouraged by this achievement, the British formed a dedicated committee to oversee the creation of a supersonic passenger jet.
The most interesting aspect of the Fairey Delta II that we see on today's Concorde was the drooping nose. Now what that is it is simply, as you see in Concorde, a nose that kinks. One of the problems with the delta-winged aircraft, and an aircraft that is designed for going supersonic speeds, is that in order to fly very fast, obviously you need something that is as aerodynamic as possible. The problem is they are very, very difficult to fly at low speeds. So when they come into land, they have a very high angle of attack, and very, very difficult then for the pilots to see what they're doing. So they then put this kink in the nose, if you like, to have this cantilevered nose, such that in takeoff and landing, to give the pilots better visibility, they put this design feature in, which we see today.
By March 1959, initial engineering had matured enough for the Supersonic Transport Committee to finalize its primary strategic proposals.
There were two main recommendations. The first was for a small, fairly simple aircraft to carry around 100 passengers and do about Mach 1.2. The second design was for a 150-seater that should have been capable of Mach 1.8, which was considerably bigger and considerably faster.
By 1959, the British thinking had crystallized into two projects. A medium-range supersonic airliner, which had a rather crazy M-shaped wing, very difficult to build. And the other project was the classic, what's now the classic long, thin delta for a supersonic airliner that could fly across the Atlantic.
This led to a pivotal resolution that would determine the trajectory of the international race for supersonic travel.
When they awarded the design study contract in 1960, the British made it a condition to BAC, who got the contract, that they should seek international collaboration for the building of the supersonic transporter.
Initially, the British Aircraft Corporation reached out to the United States, but in 1960, American officials showed minimal desire for a joint venture. Consequently, the British looked toward France as a prospective partner.
The British and French eventually decided to cooperate because the supersonic airliner project was just too big for either of them to do on their own. It was helped by the fact that the two different design teams in France and in England had more or less come to the same conclusion about what the aircraft should look like.
The resulting aircraft utilized a refined delta wing configuration. It was named Concorde, a term shared by both nations, signifying unity and collaboration. However, to gain international legitimacy, Concorde required commitments from major carriers. In June 1963, the project secured the vital contract that guaranteed its production. Remarkably, this order originated not in Europe, but from Pan Am, the preeminent American airline of the era.
Pan Am was such a good customer that they could go in and play one aircraft factory leader against another. And Tripp didn't mind going in threatening and saying, look, if you don't do this, I'm going to get somebody else to do it. And if I have to go to Europe, I'm going to Europe. Tripp was a overpowering figure in the industry at that time.
Pan American Airways had launched its legacy on October 28, 1927, completing the first scheduled international route by a U.S. carrier. A Fokker trimotor carrying mail departed Key West, Florida, arriving 70 minutes later in Havana, Cuba, covering a 135-kilometer span. Pan Am's 28-year-old visionary founder was the famed Juan Terry Tripp. It was Tripp's innovative insight that mail-carrying aircraft could seamlessly double as passenger transports. By installing seating in the cabins, he offered the Havana route for a fare of $100. Tripp was obsessed with ensuring Pan Am remained the dominant force in American aviation.
In the post-war world, in the 1960s, Pan American Airlines was one of the big names. Most American airlines tended to fly inside America, but Pan Am had built its reputation on flying all around the world. And they did that by always buying the latest and best aircraft.
On October 26, 1958, his airline became the first in the US to deploy a commercial jetliner, the Boeing 707, named Clipper America. It serviced the New York to Paris route, cutting previous travel times by 50%. Juan Tripp was equally committed to making Pan Am the first carrier to enter the supersonic age.
If you joined Pan Am as a pilot in the late 1950s or 1960s, the first thing they told you was, you hang in there, guys, because you are going to fly supersonic. Pan Am saw that being the first to be with the supersonic airliner as you know, the thing that would brand the company as the place to go.
Yet, this bold move by Pan Am was about to ignite a massive American counter-response. Just days following the June 5, 1963 announcement, President John F. Kennedy declared his administration's commitment to backing the American aviation sector in creating a supersonic transport for domestic carriers like Pan Am to operate.
When Kennedy heard that Pan American were going to buy the European Concorde, he was apoplectic. He was furious, and he phones up head of Pan Am, Juan Tripp, and just gives him a bawling out. And Tripp says, well, you know, the alternative is you give me an American supersonic airliner. So from that moment on, Kennedy decides he is going to get a hold of the American aircraft companies, and he's going to make them build a supersonic airliner faster and higher in performance than the European rival.
Thus, the competition was ignited.
The immediate result of Kennedy's intervention in the race to build a supersonic transporter was the appropriation of $100 million worth of funding from Congress, which in 1963 was a serious amount of money.
Concord finally faced a US competitor. The pressing mystery was which firm would take the lead. An anticipated contender was Douglas, the premier manufacturer of commercial planes, ranging from the legendary DC-3 to the jet-powered DC-8. However, Douglas lacked the necessary capital to enter the fray. Other prospects included North American, then developing the massive B-70 Valkyrie supersonic bomber, and Lockheed, which possessed extensive expertise in high-speed flight through the classified SR-71 Blackbird program. There was also Boeing, the architect of the formidable B-52 bomber and the successful 707 jetliner family.
Of all the American aircraft companies, paradoxically, Boeing was the one that had the most trouble in getting into the supersonic airline business. Boeing hadn't actually delivered a supersonic aircraft to anybody.
In the present day, Boeing stands as a global titan in the aerospace industry. The corporation maintains a massive workforce and provides services to clients across nearly every continent. It historically established a benchmark with revenues reaching toward the $60 billion mark. Yet, Boeing originated from very modest roots. The founder, William Boeing, was the child of a prosperous timber merchant. In 1903, he left Yale University for Washington State to seek his own wealth in the lumber trade. In 1910, William Boeing traveled to Los Angeles for the inaugural American Air Meet. He sought a flight in one of the aircraft, but not a single pilot among the dozen present would agree to take him up. Boeing returned to Seattle with the resolve to construct and pilot his own machines.
Bill Boeing was, some people think he was an inventor, but Bill Boeing was an innovator of the highest order. I think he has very few patents, perhaps if any, but he would look at a product and he could see where he could make it better.
On July 15, 1916, he established his aircraft manufacturing company in an old Seattle boathouse. He recruited shipwrights, whose woodworking precision was perfectly suited for early aviation construction. The fledgling Boeing firm flourished by producing seaplanes for the Navy and fighters for the Army. But it was the Second World War that propelled the company to its zenith.
The war was starting in Europe, and Wright Field put out an order for bids. At this time, most of the airplanes were two-engine. We were still two-engine. Douglas was doing a two-engine bomber, and another company was doing a two-engine bomber. And Boeing went in to Wright Field and said, would this procurement cover a four-engine bomber? And everybody just went berserk because nobody ever conceived of a four-engine bomber.
This was the XB-15, a four-engine prototype boasting a 45-meter wingspan.
It was so big, you could tunnel out through the wing, and you could come into the nacelle, and you could make repairs in flight.
A scaled-down variant of this Titan would achieve immortality. The B-17 Flying Fortress, which dominated the heavens during the war years.
I think they ordered 13 or 14 what they call test airplanes, and that led to the Flying Fortress. I don't remember exactly how many were built, but it was around 13,000. And that airplane then went through the A series, B series, C series, all the way to H, as I recall. I'd say the story of the B-17 was it was such a versatile airplane, was able to keep carrying more bombs, more turrets.
As men deployed to the front lines, women stepped in to manufacture the aircraft. Thousands of female workers filled the labor void, driving Boeing's output from 60 units monthly in 1942 to a staggering 362 planes per month by March 1944. The B-17 was succeeded in 1942 by the B-29 Superfortress. In Wichita, laborers, homemakers, and merchants assembled B-29s during grueling 10-hour shifts, a period famously dubbed the Battle of Kansas.
World War II transformed the fortunes of the Boeing company. Before that, it was a serious manufacturer, but planes were built in small numbers. World War II meant Boeing was producing vast numbers of giant bombers on huge assembly lines.
Following the war came the B-47, the first jet-powered bomber in the U.S. arsenal. And on April 15, 1952, test pilot Tex Johnston conducted the maiden flight of the B-52, a strategic bomber that would remain a cornerstone of aerial power well into the 21st century. Then, Boeing decided to take a massive risk.
In the 1950s, Boeing was doing quite well in military contracts for the B-47 and the B-52 bombers. But no aircraft company, can afford not to look ahead because it takes a long while to develop aircraft. And so they took a bold decision. They decided, well, let's take some of the profits from the bombers, some of that technology, and see if we could mix that into an aircraft that passengers would want to use, that the airlines would want to buy.
We had all the knowledge of the B-47, the B-52, so it wasn't too big a job in the wind tunnel to develop a low-wing airplane that could be used as a tanker, and we knew they needed a tanker, so there had to be a tanker, and we hoped it could be a passenger airplane, although we weren't really sure that that was the case. So that's why the Dash 80 was born.
The Dash 80 ascended into the skies guided by Tex Johnston, the same pilot who had mastered the B-52. Determined to prove that Boeing had engineered a superior aircraft, Johnston performed a barrel roll with the Dash 80 over Lake Washington's Seafair hydroplane course on August 7, 1955. A daring stunt typically reserved for agile fighter jets. Boeing's president, William Allen, watched from below as his company's future hung in the balance.
And Allen turned completely white, looked over at his technical advisor, Wellwood Beale, and he said, "Did we authorize that?" And then just before he could turn around, here he came back again and did it once more.
The gamble was a resounding success. The Dash 80 served as the foundation for the KC-135, the world's first jet-powered aerial tanker, which subsequently evolved into the Model 707, the progenitor of Boeing's legendary lineage of commercial jetliners. Boeing's strategy with the 707 was ingenious. Consuming roughly 1/10 of the fuel, a 5,707 could transport as many annual transatlantic travelers as the 30 million Queen Mary ocean liner. In one stroke, Boeing had birthed a new market and signaled the end of the grand passenger ship era. By 1958, as the 707 began its tenure with Pan Am, Boeing established a specialized team focused exclusively on the development of a supersonic passenger jet. By 1960, the firm was investing more than $1 million each year into the initiative. The concept was labeled the Boeing Model 733.
Boeing actually started work on supersonic passenger airliners very early on, right at the beginning of the 1950s. But in a kind of research way, is this possible? Where are the engines going? Where is the metallurgy going? But what you begin to see is by the end of the 1950s, they're starting to get quite serious about it. They're beginning to think this can be done.
Following Kennedy's directive for the United States to construct an SST, the Model 733 finally stood on the verge of becoming a reality. Through the end of 1963, the three main rivals for the American SST contract, Boeing, Lockheed, and North American, refined their blueprints in total secrecy. The industry waited to see who would prevail and what form the aircraft would take. More critically, observers wondered if a late-starting American entry could still seize the global market. By the close of 1963, fabrication of the first Concorde components was already underway in Europe. Could the United States close the gap? A historical precedent suggested it was possible. The British Comet had been the pioneering jetliner of the 1950s, but a sequence of tragic accidents exposed catastrophic design weaknesses caused by rushing the plane into service to outperform the Americans. Consequently, the Boeing 707 emerged from the shadows to dominate the airways throughout the mid-20th century.
The Americans came late to the supersonic race. They wanted to leapfrog the Europeans, and so they decided to go faster. The Europeans were going for Mach 2.2, which meant they could build Concorde out of existing materials using existing technology. The Americans decided to go way up to Mach 3 through the so-called heat barrier, which meant that because of the stresses on the plane at those speeds and the heat that would build up on the fuselage, they had to use new materials. So the Americans were going for a technological breakthrough to try and get ahead of the Europeans and bury the competition.
To eclipse both domestic rivals and the European Concorde, Boeing envisioned a craft significantly larger than its competitors, designated the 2707.
Boeing realized that if they were going to beat the Anglo-French Concorde, they would have to be bigger, better, and faster. So their design was for a faster aircraft and for one that would carry 2.5 times the number of passengers as Concorde. So instead of 120, we're looking at 277 passengers on board.
To facilitate the engineering of the 2707, Boeing constructed a massive, full-scale mock-up. The airframe spanned 93 meters in length, making it roughly 1/3 larger than the Concorde. It was designed to accommodate 277 passengers, 30 in first class and 247 in coach. This capacity was 2.5 times greater than what the more compact Concorde could offer. The interior configuration was a radical departure from the past. Until that point, Cabin layouts consisted of narrow seating flanking a single aisle, which often created a claustrophobic environment for travelers.
Boeing decided that in order to entice people into this new aircraft with these fancy speeds, they'd have to offer a bit of something else. And so they made the fuselage bigger so they could get more seating in. Today we are very used to three sets of seats, 2 aisles. But this was the first time when Boeing was developing the supersonic airliner that they decided to introduce that into an aircraft.
In contrast, the Concorde featured a very slender fuselage and the traditional 2-abreast single-aisle configuration. The 2707 was intended to be propelled by 4 massive turbojets, each engineered to produce nearly 30,000 kilograms of thrust. During takeoff, the combined power would rival the output of several dozen heavy locomotives.
The Boeing 2707 had 2 other very interesting features. The first was a drooping nose, not unlike we see on Concord today, to allow the pilots much better visibility in takeoff and landing, and then to be flicked up for that needle-like high-speed flight. The second design feature was also to do with the differences between low speeds for approach and landing and high speeds in supersonic, and that was the swing wing. The wing was able to pivot for those slow speed areas, making it easier and safer to fly when taking off and landing. But then when it was up above the Atlantic or Pacific or wherever it was going to go and approaching its speeds of Mach 2, you could sweep the wings back and get a very similar effect to the Delta.
The wings on the Boeing 2707 prototype mock-up were designed to sweep manually, shifting from a fully retracted 72-degree angle for high-speed cruise to a 30-degree extension for stability during takeoff and landing.
The Boeing supersonic airliner was really pushing the boundaries of aviation technology. They were going to go faster, they were going to go faster for longer, which meant new materials, new kinds of engines, new kinds of avionics. It was a risk.
Lockheed, a major competitor, remained skeptical of this complex swing-wing design while finalizing its own entry, the Lockheed L2000.
The Lockheed design for a supersonic airliner was simple, elegant, beautiful. No complex moving parts like a swing wing. They'd adopted the narrow delta that everyone knew was going to work. It was within the boundaries of what was possible. They were minimizing the risks, and that's why it was a serious competitor.
As the deadline for final design submissions approached, Boeing continued its ambitious strategy to overshadow all rivals.
As the design process went on, it became obvious that the Boeing entry was going to be terribly complex, terribly expensive. That made the airlines who were going to have to buy and use the thing frightened. So Boeing started adding on more and more passengers in the hope that it could make a profit that would make up for the escalating costs of the aircraft in the first place.
Size does help you a little bit on efficiency, at least it has on the other airplanes, and so obviously you can go overboard and be too fast, but too big. But I think that we felt the Concorde was too small to be a successful system.
On the final day of 1966, the winning design was officially declared. The revolutionary Boeing proposal had secured the contract.
I think it was a very tough competition. The reason we won the configuration was not necessarily that the airlines liked our configuration any better. My personal opinion is that I think that they felt that they would rather have Boeing build their commercial airplane than the other 2 manufacturers, because we were in the process of building commercial airplanes at that time and working with the airlines, and my personal opinion is that we were picked as a company, not as a design.
It was a surprise that Boeing won because they had so little experience in building working supersonic aircraft. I mean, they were famous for the B-52 bomber, which is subsonic. Everyone else, I mean, Convair, Lockheed had built large and fairly successful supersonic aircraft. So this was the new guy on the block suddenly being given the job, and everyone thought, can they do it?
Boeing's leadership forecasted that if prototype construction commenced in early 1967, a maiden flight would occur by 1970. They projected that the first aircraft would enter commercial service by mid-1974. In retrospect, these timelines were entirely unrealistic.
The main problem in designing the Boeing supersonic airliner can be summed up in one word: the weight. This thing just got fat. It got heavier and heavier. It wasn't going to make money. They had to then strip out weight, and in the end, the biggest weight penalty was going to be the mechanism to make the wings swing.
As we got beyond the preliminary design stage to build it, the weight got too heavy. The empty weight got too heavy. That was the main problem. The weight just got out of hand, and we couldn't meet the weight statement that we'd estimated for the configuration at the start.
The program ground to a standstill for an entire year as Boeing explored alternative configurations. By October 1968, the company presented a version that was essentially a total redesign.
There was only one way to solve the weight penalty problem. That was to take the swing wing out.
Boeing's swing wing disappeared mostly because of the extra weight. That huge hinge in there was very, very heavy.
The revised 2707 was smaller, with seating capacity dropped to 234 passengers, though it still remained larger than the Concorde. However, a new crisis emerged that would plague the project and ultimately lead to its demise: the sonic boom.
We knew it existed, but frankly, I didn't think it was that bad. The sonic boom that the airplanes we were talking about was like thunder and lightning, where the thunder hits about 2 miles away. And I guess I just didn't figure it was that bad.
In order to explore the effects of the sonic boom on, for example, urban areas, the American Air Force conducted an experiment in 1964, which is something I don't think we would ever contemplate doing today. And what they wanted to do was see what effect it had on an urban area. So they they flew supersonic bombers over Oklahoma City with sonic booms or waves of shocked air passing all the time. The result was that in a very short period of time, they had around 8,000 very vocal complaints and around 5,000 complaints for claims for damages.
In 1967, following Boeing's selection, Harvard scientist Dr. William Shercliffe founded the Citizens League Against the Sonic Boom.
Well, actually, there were so many technical and economic hurdles that had to be addressed for an airplane like this. Not the least of which was the sound. Breaching the sound barrier always created shock wave over populated areas.
Well, that era was a miserable era for me, because here I was, an engineer trying to do things, and you had these idiots back there making. It was a political situation, and he just jumped on it. This guy Shercliffe, I never met him. I don't know what his problem was. I know the British were taken by surprise on it. They were completely amazed at the problems we were getting.
Other researchers theorized that SST exhaust released in the stratosphere could trigger a self-sustaining chemical reaction. They warned this would deplete the ozone layer, reducing its ability to absorb radiation and potentially leading to a rise in skin cancer cases.
I think there were other environmental concerns, perhaps not substantiated technically, about the ozone layer, about contamination of the upper atmosphere. There were all sorts of boogeymen shoved into the front of the table having to do with so-called environmental problems.
Public sentiment shifted sharply against the project, and as opposition mounted, Congress began to voice serious reservations about the aircraft's viability. In response, President Richard Nixon, shortly after his 1968 election, formed a 12-member committee to evaluate the program's future.
Nixon was a firm believer in the SST when he came to power, like Presidents Johnson and Kennedy before him, and he felt that the SST was essential to American prestige. And in order to underline the case for the SST, he appointed a committee. To his great surprise, I think, and consternation, the committee came out against the SST and decided it was completely unviable.
Beyond the environmental concerns, the Boeing SST was struggling with performance goals. When President Kennedy first established the program's objectives, he had mandated that the American transport must surpass its European competitor by reaching a speed of Mach 3. Yet at such velocities, an aircraft's exterior becomes incandescent. Engineers must utilize exorbitant materials capable of enduring these temperatures without warping or fracturing.
To reach the speed that the 2707 was going to go at, you had to find new materials to deal with the buildup of heat. The most effective material would be titanium. And at that time, titanium was really, really complex to machine, very expensive to get a hold of. It was going to make the whole project uncommercial.
It's tough environment, and temperatures in Maine is a real big problem. And whether you can ever design a structure to meet all this and still have enough left over to make any money with is not too clear at this point.
The British had concluded long ago that these thermal hurdles were too complex and costly to overcome. Concorde was designed to cruise below 2,000 kilometers per hour, significantly mitigating the friction-induced heat. This allowed the Concorde to be constructed from conventional aluminium alloys, keeping production expenses manageable.
You went much faster than Mach 2. We got too hot for aluminum. I don't know, aluminum, I can't tell you exactly, but you wouldn't want to go too much beyond 2 to get to with aluminum, so you needed a better material. And titanium was quite capable. It was a good material, and we felt that it would be. So part of the program was learning how to manufacture.
As Boeing specialists struggled with these obstacles, the 2707 initiative faced relentless setbacks while expenditures surged.
We spent several $1 million of our own company money in working titanium on the side of the outside of the contract on the SST, but maybe we were too ambitious. It might have worked at 2.5 Mach number, but I think that you go 3 and that's 400 degrees, and that's too hot.
On May 18, 1971, the United States Senate convened to vote on terminating the SST project's funding. Despite President Nixon's intense lobbying to sustain the program, his efforts failed. By a vote of 58 to 37, the Senate effectively ended the life of the Boeing 2707.
I think that Kennedy's decree that the SST should be bigger, better and faster than the European rival did cause major problems for Boeing and for the whole project right throughout it, because they were always aiming for this kind of Kennedy standard of Mach 3 and all the problems that are associated with flying at Mach 3.
I think that was too hard. It just wasn't practical. I think we could go faster than the 2. I think 2.5 would have probably been okay from a temperature standpoint, but certainly any higher than that would have probably not been practical.
Europe appeared to have claimed the technological crown. In 1973, just 18 months after the American project was dismantled, Concorde touched down in the USA for the opening of the new Dallas-Fort Worth Airport. During its 4-day Texas residency, it performed supersonic exhibitions over the Gulf of Mexico, becoming the centerpiece of the airport's dedication ceremonies. However, it soon became evident that Concorde's triumph was hollow. The same issues that doomed the 2707, most notably the sonic boom, now hampered the European jet. British Airways launched its inaugural supersonic route between London and Bahrain on January 21, 1976. Because the path was largely over land, the aircraft was forced to fly at subsonic speeds for significant portions of the journey. A subsequent service to Singapore faced an even shorter lifespan. By December 13, 1977, after only 3 flights, The route was halted due to environmental protests from the Malaysian government regarding sonic booms over the Straits of Malacca.
Ultimately, Concorde, though it made it into passenger service, it suffered the sonic boom problem that had dogged the early Boeing project. The Americans banned supersonic flight over the continental United States. Some people said that was in retaliation. Whether it was or wasn't is neither here nor there. It meant that Concorde could only fly supersonic over the Atlantic.
It couldn't meet any of the requirements that we couldn't meet, and it still can't, but there's so few of them that nobody cares. They don't meet the sonic boom, and they don't meet the takeoff noise, and I guess there are probably only half a dozen or so flying in each airline.
Concorde will never be profitable in the sense of making back the money that it cost to buy or to develop. As far as the airlines are concerned, well, Concorde makes money on an individual flight-by-flight basis because it can charge very high tickets to the kind of luxury passengers that are there.
The system exists now because it's unique and it's high cost and it's one of a kind. And if you want to make a splash, you go over on the Concord. And okay, Betsy and I were on it. Well, we went over, take off from Washington about 4:30 in the. We took off from Washington about 4:30 in the afternoon. And you're in a hotel room in London, 9 o'clock. It's great.
Yet one hidden chapter of the Boeing 2707 saga would eventually democratize global travel. On December 22, 1965, Boeing's William Allen and Pan Am's Juan Trippe signed a commitment for 25 units of a new transport concept. While the 2707 had been Boeing's primary focus, this new project was treated almost as a secondary concern. Boeing chose simplicity, scaling up the existing 707 architecture. They designated it the Model 747, though the world would come to know it as the jumbo jet.
The 747 is an amazing story. And it started back right after the Vietnam War, where the government said, we need to move a lot of material and a lot of people around the world in a hurry.
The 747 was actually developed in tandem with the Boeing supersonic project. And the aim was to put in the 747 what you couldn't get in the supersonic aircraft, which was freight. It was just meant to be a big cargo plane in the first place.
The Boeing company in 1965 decided to scale up the 707, I think as a freighter originally, but it was soon realized you could pack so many people into these aircraft and fly them at high subsonic speeds that it was very, very commercially viable, made great sense.
When the dream of supersonic commercial flight faltered, the 747 stepped in to fill the void. Entering service in 1970, it ignited a true revolution, making long-distance flight affordable for the average family. The era of mass aviation had arrived. Historically, over 1,500 of these Queens of the Skies were produced, dwarfing the mere 14 Concordes that ever reached commercial service.
I think the 747 will still be flying in 20 years. It's one of the major developments of this century in aerospace.
Curiously, there's one hangover from the old supersonic project that ended up in the 747, and that was seating arrangement. When they transformed the 747, the jumbo jet, into a passenger plane, because it was wide-bodied, they could put in a couple of rows, you'd get a lot more seats. And that was the original dream that the supersonic transport had been born with.
Boeing's fascination with high speed didn't vanish with the 2707. In a later collaborative effort, NASA utilized a retired Soviet SST, the Tupolev Tu-144, often called Concordsky, as a flying laboratory.
The Russian SST actually flew just a few months before Concorde. And when people saw it, they said, gosh, that looks like Concorde. And that's because, of course, the Russians had stolen, line for line, page for page, the plans of the Concorde and built it themselves.
The Tu-144 never succeeded internationally. It was difficult to operate and fundamentally compromised. Its final mission was to help modern engineers understand the environmental issues that had plagued the 2707. NASA and Boeing envisioned a successor capable of carrying 300 passengers at 2,400 kilometers per hour, crossing the Pacific in just 4.5 hours. Ironically, these were nearly the exact specifications of the 2707, cancelled decades prior.
The main thing that's happened is you've gone to high bypass ratio engines, and the engine cycles changed, and the noise problem isn't as bad as it used to be with a pure jet.
Years of research provided better insights into supersonic flight, but the fundamental barriers remained: high operational costs, noise, and emissions.
There is no technology anywhere that I'm aware of that says that you can bypass, overpass, whatever, the supersonic barrier. It's there. The boom just has to be there. There's so much energy involved when you go through that barrier.
The dream of supersonic transport was an engineer's dream, it was a politician's dream, it was Kennedy's dream. The passengers wanted something different. They wanted cheap tickets, they wanted reliable service, they wanted comfort, and that will always be the future of the airline business.
Now, as a matter of fact, if somebody were to ask me today, will there ever be a supersonic airplane in the U.S., built by the U.S., I would say first you got to define what you mean by supersonic. There may very well be a more advanced Mach 2 airplane, larger, more economical, and so forth than the Concorde. They may very well be, I don't know that. But we are still today not ready in materials to go to Mach 3. We just don't have the wherewithal to do it.
Yet the ambition persists. Even in the 2020s, aerospace companies are developing new boom reduction technologies to push the limits of speed. While the legendary SR-71 Blackbird once routinely cruised at Mach 3 using titanium, modern materials science continues to evolve. As we move through the 21st century, the goal remains to make the dream of routine supersonic travel a reality. This is the enduring legacy of the Boeing 2707, the most influential aircraft that never actually left the ground. During the summer of 1963, President John F. Kennedy unveiled a significant new aviation initiative.
Our strong faith in the future.
He challenged America to develop and operate a supersonic jet capable of cruising beyond 3,000 kilometers per hour.
Program in civilian aviation. Supersonic flight.
This narrates the tale of Kennedy's vision, a machine at the absolute frontier of engineering. A craft intended to soar quicker and loftier than all competitors, the Boeing 2707. Among John Kennedy's inspirations was John Glenn, the initial American to orbit Earth. Yet Glenn was also the pioneer who crossed the American continent at supersonic velocity back in 1957. From that moment on, Kennedy had envisioned creating an American supersonic passenger transport. Different nations shared that ambition.
The British began their supersonic aircraft program in 1943, midway through the war. It was a design, obviously, at that stage, which called for an aircraft to be capable of Mach 1.5. That's 1.5 times the speed of sound, or about 1,000 miles an hour, which is really quite adventurous when you think about the speeds they were achieving in those days.
The British pursued various concepts. Notable examples included the Miles M52 and the de Havilland DH-108 Swallow. However, Britain lost the ultimate race to Chuck Yeager, piloting the American Bell X-1.
To tell you the truth, I was hopping mad because I realized we could have done it and we'd missed the boat by cancellation. Not with the DH-108, but with the Miles M52. I was to be the pilot of the Miles M52, so I'd followed this carefully, and we were 80% ready for the first flight, when, without any warning, without any consultation, the aircraft was cancelled.
On October 14th, 1947, the rocket-driven Bell X-1 stood as the first plane to exceed the speed of sound.
The British were really upset that the Americans had been first through the sound barrier, because British technology was ahead of the Americans. The British just fluffed it.